Well, we have a different scenario now, and it's velocity that we're dealing with of a high-speed, short-range commuter shuttle that runs east to west. Again, I've got this east-west thing going on for positive direction, negative direction, just from our point of view. From a station located at position 0. It's represented by that function there, where velocity is measured in miles per minute. So we're dealing with miles per minute, which is a thing. I actually rode a very high-speed train one time. That's off topic. And people start skipping through the video. I rode a very high-speed train one time in China, and it was about 200 miles an hour. It was incredible, absolutely incredible. You look out the window and it would make you dizzy how fast things were going by. Anyway, let's graph this. We'll pretend like it's calculator inactive. Let's not use that color. Let's use this color. Here goes. This has a vertex at 3, -4. So 3, -4. There we go. And it is absolute value, so it's going to go like this. Let's get the slope just right, though. I don't even know what that was for. There we go. The slope is 2. So rise 2, run 1, rise 2, run 1. Rise 2, run 1, rise 2, run 1. There we go. And we're going to do this all the way to 8. And then we'll back up and do a -2 slope here. And let's connect them. So on the front side of these notes, we just talked about the area under the curve of a velocity function and how it represents the distance that you traveled. So just to refresh your memory, you may flip your paper over if you like. I'm going to grab that piece of paper, which is at the very bottom of a very thick stack. Here we go. The area here represented the number of miles that you drove, and it was an oversimplified example of it. We're going to do the same thing here. All right, things are going to get crazy. Graph the function, done. Determine how far and in what direction the train traveled for each of these time intervals from 0 to 1. So here's what I want to do. I'm going to shade this to the best of my ability. From 0 to 1, this is how far the train traveled. This, what do you mean this? This area. What area? That red space from 0 to 1. Well, what is that red space? It's a triangle, so it's 1/2 times base times height. Its base is 1, its height is 2, so 1. Okay, 1 what? Well, let's look at the problem and make sure we're doing this correctly based on units. Miles per minute. We traveled, in the first minute, we traveled 1 what? Mile. Okay, which direction did we travel? Okay, now east-west is important. We traveled 1 mile. We traveled positive 1 mile because we were traveling positive 1 mile. We were going to the right, and based on our perceptions of where we generally look at maps, we'll just go with that assumption that we're not turning the map upside down. We are going to have 1 mile to the east. And if you want to get technical, it's 1 mile to the right. There we go. All right, let us proceed. We're going to go from 1 to 5, and I'm going to color that one a little differently. Probably should have colored the top a different color other than red, because usually red represents negative, and this one's going to be negative, but man, look at that beautiful coloring there. That is just lovely. Outside the lines and everything. Equal shading. Never was good at coloring, but enough of my life. So that shape is obviously a triangle. We'll do the same thing here. So we have 1/2 base. The base is 1, 2, 3, 4. And the height is 1, 2, 3, 4. And there's an awkward shadow being cast right there. I apologize. Oh well. So 1/2 4 times 4 is going to give me 8. Now, let's be real honest with ourselves, though. This is not 8. This is no regular 8. This is 1/2 4 times, what's the height? Okay, height's never negative, but for our purposes, we did have to go down to get there. So let's call that a -4, which makes that a -8, which means I am about to, just because this shadow is in my way, I am going to slide the table. There we go. That fixed it. Now you can see my shoes and socks and everything. All right. Crisis averted. We're back on track here. Track, get it? Because it's a train problem. -8. So we traveled -8 miles. Miles. I put a dot over the E just for fun. -8 miles. Okay, -8 miles. You can't travel negative distance. I hear you. I hear you. Which is, here's what that really means. I traveled 8 miles to the west which is also to the left, okay? All right, I did not want to say, I was really cautious that I didn't word it this way, -8 miles west, because if I'm going west is negative from our perception, so negative because of west and negative because of negative, that would really mean I'm going 8 miles east. Okay, it's a double negative, it's wordy, it's confusing, so let's not go there. I want to go from 5 to 8, so minute 5 to minute 8 would be this. That's the music they play on the train. People can't wait to get off that train. Boom, pow, pow. There we go. Positive or negative? Positive. The area is positive. Area is never negative, but area can be computed using negative numbers, like the value of this function was -4, and that's why we ended up with a, watch the fingers, quote unquote, negative area. Negative area on this graph of velocity with a train. Let's keep going. Anyway, we have another triangle, so 1/2 base. Base is 3. Height is positive, in this case 6. And so that would give me, well, 9. 9 miles. And it is positive, so we're going to go 9 miles to the east, which of course is to the right. All right, let's proceed. What is the total distance the train traveled for the first 8 minutes of this trip? So you might be tempted to say 1 minus 8 plus 9. No, it's 1 plus 8 plus 9, because I am traveling here as I go 8 miles. But I am traveling in a negative direction based on the perception of what I deem to be positive or negative. So let us move on with a different color. Total distance that I traveled is 1 plus 8 plus 9, which of course is 18 miles. That does not come as a surprise to anyone. Here's really what I will do in different circumstances later on when we're dealing with this from a more complicated point of view. What I would do is basically take the absolute value of this function. I know you're like, but it's an absolute value function. Yeah, that's great. But it would flip everything up. And then I would be like, I traveled this distance and this distance and this distance, and I never would count anything negative. It's just a handy way of doing things. We will cross that bridge in a later lesson, but it was worth talking about that bridge before we got there. How far is its starting position? How far from its starting, let's read together now. How far from its starting position is the train at the end of 8 minutes? Okay, the train began, I don't know where it began. Okay, it was located, the station is at position 0. Does it say where it begins? No, actually not till you get to question 10. And if you're looking down, you're like, oh, there it is. We don't know that yet, so we're still on question 9. But we just traveled 1 mile to the east for the first minute, and then 8 miles to the west, so I am using the signs here, and then 9 miles to the east, and in the process of doing that, I'm going to have 2 miles, and it is 2 miles to the right. I'm going to call it 2 miles east of its, no apostrophe on its there, starting position. Sorry, grammar. Starting position. Okay. Assuming that the train started 5 miles east, to the right, of the station, where was the train at the end of 8 minutes? Okay, now we know where it started. The train, we need to draw this train. Here's your train track right here. That's the station. This is the station. And so 1, 2, 3, 4, 5, 6, 7, not drawn to scale. There we go. Let's fix that. This is going to look very middle schoolish, but bear with me here. Here goes the train. Choo choo. Sorry, couldn't resist. Here goes the train. Assuming it starts at the station, and it doesn't, it would go 1 mile to the east, and then 8 miles to the west. 1, 2, 3, 4, 5, 6, 7, 8. We're dealing with a number line. I know we passed number lines years ago in several other classes, but we're back to this idea. It's the same idea. It's beautiful how it all ties together. I just lost my track. My train of thought. I got off track. Woo, the jokes. 1 forward, 1, 2, 3, 4, 5, 6, 7, 8 back, which puts us at -7. And then 9 forward, 1, 2, 3, 4, 5, 6, 7, 8, 9. We are, again, 2 miles east of where we started. If we started at the station, but we didn't start at the station, that sounded very deeply Southern. We didn't start at the station. We started 5 miles east of the station. This is our starting position. So we would do the same thing. Go 1, back up 8, go forward 9, and we would end up here at 7. Don't make it harder than it is. The answer is 7, and again, here's why. This is where we start, and I know you're like, man, I got it. If we don't do this now, then we might miss some of the bigger concepts later when it's more complicated for real. So we start here, and then we had a net gain of 2 miles. And so we end here. I know you know 5 plus 2 is 7. I get it. We start here. We gained 2 miles and we end here. This is, for real, this might look so elementary, but it's going to be so important because later we will be dealing with some calculus where we'll have to do some crazy things up in here to figure out what the net gain is, and we'll have to remember to add it to where we started to figure out where we ended. It won't always be a train on a track looking like a number line, but I wanted to start with this example. There you go.